Hi students, good morning. In this class, we will discuss to chapter 5 Binomial Theorem, Sequence and Series. Sequence and series. Here, first of all, we know that the meaning of this chapter. Okay, here by means. Okay, by means. What is mean by by? By means two. Okay, by means two. Binomial. The word binomial means the word binomial. Binomial means have expressions having sum of two terms. Okay, expressions having sum of two terms. Having sum of two terms. Sum of two terms. Okay, for example, here we take A plus B. Okay, A is one term and B is another one term. Sum of two terms, that is called the binomial. Okay, and 1 plus xy. This is another one example. 1 is one term and the xy is another one term. Sum of two terms. Okay, x plus y z. Okay, x plus y z. Similarly to the same process. Okay, etc. Sequence means, what is mean by sequence? Sequence and series. Here, sequence means, for example, 2, 5, 8, 11, 14, and so on, like these types. For example, in the beginning, first one is 2, 5, 8, 11, 14. We take any two numbers, relations between putting comma. Okay, relations between putting comma is like as sequence. Okay, is like as sequence. Then the series is 2 plus 5 plus 8 plus 11 plus 14 plus and so on etc. Okay, here the connecting two numbers, then the relations between, that is operations between using addition symbol. Okay, using addition, that is called the series. Okay, that is called the series. Okay, here binomial theorem. Go to the binomial theorem. Theorem. The word binomial expression as having sum of two terms, isn't it? Yes. For example, a plus b. Okay, a plus b. The whole power n. Okay, here the whole power n like as only defined. A plus b the whole power n. The n like as only positive number. A plus b the whole power n expansion is defined only for the positive numbers. Okay, n like as only positive numbers. Positive numbers. It can be expanded. Okay, otherwise n like as negative values doesn't expand. Okay, is not defined. The value of n like as negative means does not define. Okay, here already we learn NCR. Okay, NCR, which is equal to n factorial divided by difference of 2. Okay, here n minus r factorial into r factorial. Okay, n minus r factorial into r factorial. Okay, here now expanding a plus b the whole power n. Okay, whole power n. Here n c naught. Okay, the beginning is n c naught. The term a power n. Okay, a power n minus 0. Okay, n minus 0 and b power, okay, b power 0. Here a power is difference between n and r, that is n minus 0, and b power is r. Okay, b power is r, plus the next term nc1. Okay, a power n minus 1, b power 1, plus nc2, a power n minus 2, b power 2, plus and so on, plus ncr, a power n minus r, b power r, plus and so on. Then the last term is ncn. Okay, ncn, that is a power n minus n and b power n. A power n minus n is 0. Okay, a power 0 is, anything power 0 is value 1. ncn is value 1. That is the last term is only contain b power n. Okay, only contain b power n. This is the binomial expansion of a plus b the whole power n. Okay, a plus b the whole power n. Suppose a minus b the whole power n is, okay, a minus b the whole power n is connecting between the relation using subtraction symbol, means the sign like as alternatively. Okay, the sign like as alternatively. In the beginning is plus, the next is minus, plus minus, plus minus. Okay, here n c naught, a power n minus 0, b power 0, minus n c 1, a power n minus 1, b power 1, plus n c 2, a power n minus 2, b power 2, minus n c 3, a power n minus 3, b power 3, plus and so on, plus minus 1 the whole power r into, okay, minus 1 the whole power r into ncr, a power n minus r into b power r, plus and so on. Then the final term is minus 1 the whole power r into ncn into a n minus n b n. Okay, here n minus n is 0, a power 0 is 1, 1 into bn is bn, nc, the value of ncn is 1, 1 into bn, then the product of the sign. Okay, a minus b means the sign like as alternatively, plus minus, plus minus, plus minus. Okay, here this is an expansion of a plus b the whole power n, this is expansion of a minus b the whole power n. Okay, here then the properties, number 1, a plus b the whole power n. Okay, a plus b the whole power n, this is the expansion is summation r equal to 0 to n. Okay, r equal to 0 to n. Here n c r. Okay, n c r, a power n minus r, b power r. Okay, this is an expansion. Okay, summation r equal to 0 to n, ncr, a power n minus r, b power r. Substitute r equal to 0 into here nc naught, a power n minus 0, b power 0. Okay, that is the first term. Okay, substitute r equal to 1 means nc1, a power n minus 1, b power 1. That is the second term. Okay, second term of the expansion. Substitute r equal to 3, 4, 5, 6 up to the finite term n. That is the last term. That is constant term. Okay, that is constant term. Okay, or otherwise summation r equal to 0 to n, ncn, a power r, b power n minus r. Okay, both are the same. Both are same. Okay, And the second one is a plus b the whole power n contains exactly n plus 1 terms. Okay, n plus 1 terms. For example, we take a plus b the whole square. Okay, a plus b the whole square. Here the value of n is 2. Okay, value of n is 2. Then the result is n plus 1 terms, that is 2 plus 1 is 3 terms. Here a square plus 2ab plus b square, isn't it? The whole power 2 means exactly the expansion containing 3 terms, n plus 1 terms. 2 plus 1 is 3 terms, 1, 2, 3. For example, a plus b the whole power 3 means the expansion have 4 terms, isn't it? Expansion have 4 terms. For example, a power 3 plus 3 a square b plus 3a b square plus b power 3. 1, 2, 3, 4. Okay, similarly to the same process up to the finite number. Okay, finite numbers. Next, property number 3, a plus b the whole power n. Okay, a plus b the whole power n in general. Okay, now we take a plus b the whole square. Okay, a plus b the whole square using NCR formula, that is binomial theorem. N is 2c naught a power 2 minus 0. Okay, 2 minus 0 b power 0 plus 2c1 a power 2 minus 1 b power 1 plus 2c2 a power 2 minus 2 b power 2. Okay, b power 2. The whole power 2, it means n like as 2 means the expansion containing 3 terms, isn't it? Expansion containing 3 terms. Here then the concept is each term. Okay, each term, the degrees of a, the degrees of the powers of a decreases to 1. Okay, decreases by 1, and powers of b increases by 1. Okay, increases by 1 in each terms. Okay, in each term. For example, here in the first term a power 2 minus 0 is 2. Then the next term a power 2 minus 1 is 1. Okay, in the last term a power 2 minus 2 is 0. A power 2, a power 1, a power 0. Then the powers of a decreases by 1 in each term. Okay, here in the first term b power 0, the next term b power 1, the next term b power 2. The powers of b increases by 1 in each term. Okay, however, the sum of powers of a and b, okay, in each term, sum of powers of a and b, here 2 plus 0 is 2, like always n. Okay, like always n. In these terms 2 minus 1 is 1, 1 plus 1 is 2. Okay, here 2 minus 2 is 0, b power 2 is 2, 0 plus 2 is 2. This is the concept. In each term the powers of a decreases by 1, and same time the powers of b increases by 1. Okay, in the sum of powers of a and b is always n in each term. Okay, always n in each term. Okay, here the powers of a decreases by 1, and the powers of b increases by 1. Okay, increases by 1. In same time, sum of powers of A and B is always n. Okay, sum of powers of A and B in each term is always n. Okay, always n. Okay, next go to property number 4. Property number 4, a plus b the whole power n. Okay, expanding using binomial theorem, r plus 1th term is, okay, find the r plus 1th term. The term is t r plus 1, which is equal to here ncr a power n minus r b power r. Okay, then the r plus 1th term is t r plus 1, which is equal to ncr a power n minus r b power r. Okay, here the property number 5. Suppose the expansion of binomial expansion whole power n. Okay, whole power n like as even means. Okay, if n is even, okay, n is even, n is equal to even numbers. Suppose n is equal to r numbers. Okay, r numbers, then the greatest coefficient is, okay, greatest coefficient is, to find greatest coefficient, find greatest coefficient is same, which is equal to t n by 2. Okay, t n by 2. Okay, or nc n by 2, or any one. Okay, or nc n by 2, or nc n by 2. Okay, nc n by 2. Suppose if n is equal to r numbers means greatest coefficient, which is equal to n c n minus 1 by 2 or n c n plus 1 by 2. Okay, n c n minus 1 by 2 or n c n plus 1 by 2. Okay, next another property, a plus b the whole power n, the principle of binomial theorem. Okay, expanding a plus b whole power n, if n which is equal to like as even numbers. Suppose n like as odd numbers. Okay, odd numbers, then find the middle term of the expansion. Okay, find the middle term. To find middle term of the expansion. Okay, of the expansion, which is equal to t here t n by 2 plus 1. Okay, t n by 2 plus 1. Suppose n which is equal to odd number means, okay, odd number means middle term. To find middle term of the expansion, is t n minus 1 by 2 plus 1. Okay, t n minus 1 by 2 plus 1, or then the another one is t n plus 1 divided by 2 plus 1. Okay, like as t n minus 1 divided by 2 plus 1 or t n plus 1 divided by 2 plus 1. Okay, Next go to another property, a plus b the whole power n. By the principle of binomial theorem, expanding a plus b whole power n. Okay, this is the equidistance from beginning and the end. From the end are equal. Okay, equidistance from beginning and from the end are equal. Okay, end are equal, that is same distance. Okay, that is same distance. It means NCR, which is equal to NC n minus R. Okay, NC n minus R, that is the equidistance from the beginning and from the end are equal. For example, a plus b the whole power 3. Okay, a plus b the whole power 3. Okay, here 3c naught a power 3 minus 0 b power 0 plus 3c1 a power 3 minus 1 b power 1 plus 3c2 a power 3 minus 2 b power 2 plus 3c3 a power 3 minus 3 b power 3. Okay, here 3c naught, the values of 3c naught is 1. Okay, a power 3 minus 0 is 3, b power 0 is 1. Okay, 1 plus the second term is 3c1. 3c1 is 3, a power 3 minus 1 is 2, a square, b power 1. Okay, plus here 3c2 is 3, a power 3 minus 2 is 1, b power 2 plus 3c3 is value is 1, a power 3 minus 3 is 0, b power 3. Here a power 0 is 1 into b cube is b cube. Here what is the equidistance? Which is the equidistance? For example, the expansion of a plus b the whole power 3 containing 4 terms. Isn't it containing 4 terms? In the second term, okay, in the second term the distance is 3. Okay, distance is 3. In the second term from the end, okay, second term from the end, this is the first term of end, this is second term from the end, isn't it? Yes. Then the distance are the same. Okay, distance are the same, that is the equidistance. Okay, that is the equidistance. In the here consider, we conclude another one result. In the expansion a plus b the whole power n, in general expansion, in the first term the coefficient is 1, always begin with 1 and end with 1. Okay, in the expansion of a plus b the whole power n, in general, in the first term and the last term containing the coefficient is always 1. Okay, always 1. Now we discuss to particular value of binomial theorem. Okay, binomial theorem. Here we take 1 plus x the whole power 1. Okay, the principle of binomial theorem, expanding 1 plus x the whole power n, which is equal to nc naught 1 power n minus 0 x power 0 plus nc1 1 power n minus 1 x power 1 plus nc2 1 power n minus 2 x power 2 plus and so on. Similarly to the last term ncn 1 power n minus n x power n. Okay, simplify we get that is nc naught is 1, expanding 1 power anything is 1, x power 0 is 1. The first term is 1 plus the second term is expanding 1 power anything. Okay, 1 power anything is 1, nc1 x power 1 plus the second term nc2 x power 2 plus third term nc3 x power 3 plus and so on plus ncn is the value is 1, 1 power n minus n is 0, anything power 0 is 1, x power n, that is the last term. Okay, that is the last term x power n. This is the expansion of 1 plus x the whole power n. Here when x equal to 1, okay, x like as 1, substituting x equal to 1 means 1 into nc1 nc1, 1 into nc2 nc2, 1 into nc3 nc3. Similarly to the same process, the last term is 1. Okay, here that is 1 plus nc1, the 1 can be written as nc naught. Okay, nc naught plus nc1 nc2 plus nc3 plus and so on plus the final term is ncn which is equal to 2 power n. Okay, which is equal to 2 power 1. This is the particular value. Okay, nc naught plus nc1 plus nc2 plus nc3 and so on plus ncn which is equal to 2 power n. Here we take another one expansion 1 minus x the whole power n. Okay, 1 minus x the whole power n. The expansion is 1, that is nc naught minus nc1 x plus nc2 x square minus nc3 x power 3 plus nc4 x power 4 minus and so on. And the last term is minus 1 the whole power n. Okay, minus 1 the whole power n into ncn x power n. Okay, x power n. Here when substitute x equal to 1. Okay, substitute n x equal to 1. X equal to 1 means in the result like as nc naught minus nc1 plus nc2 minus nc3 plus nc4 minus and so on minus last one is minus 1 the whole power n into ncn. Okay, ncn. Here the collecting, here we collecting the even number of, okay, collecting the even numbers, that is nc naught plus nc2 plus nc4 plus and so on the even numbers which is like as nc1 plus nc3 plus nc5 plus and so on which is equal to, both are equal to 2 power n minus 1. Okay, 2 power n minus 1. Okay, this is another one result. This is another one result. Okay.